So this video is really about our geometric understanding of what an integral is. And what I would like you to do is to use geometry to obtain the value of this definite integral. And afterwards you can check your result by performing the integral, but first of all, just use your understanding of what a definite integral means and geometry to work out the value of this integral. So have a go, please, with pen and paper, and then after you've had a go, you can come back and solutions and comments are on the next 2 slides. Okay, welcome back. Let's look at the solution. So what we want to do is to understand geometrically the value of this definite integral. And I'm just going to draw here before I go through this solution here. I just want to draw a basic geometric intuition. So if we have a function, and let me just draw it here. So it doesn't matter what our function is, something like this, say. And we want to integrate from a to b. This function, y, is some function of x. Then the integral from a to b of our function of x with respect to x is going to be given by the sum of all the area above the x-axis and between the curves, so this area, say, and this area, minus any area which is between the x-axis and the curve and is below the x-axis. So area above counts positively to an integral, area below counts negatively to an integral. So if I call this area, let me say A1, and let's say that we call this area A2, and this area A3, then our definite integral here between what we're calling A and B would be A1 minus A2 plus A3. So this is our key geometric intuition, and that's what we are going to use now to understand what's happening. So just as here we sketch the integrand, so here we sketch this integrand. This integrand is a straight line. Y is 1 minus 2x is the straight line. At x is minus 1, it is at 3, because 1 minus 2 times minus 1 is 1 plus 2, so it's 3. At x is equal to 2, it is 1 minus 2 times 2, so it's 1 minus 4, so it's at minus 3 down here. And it crosses the x-axis at x is equal to a half, because if this is 0 and y is 0, 1 is equal to 2x, so x is 1 over 2. And it's not so important, but it crosses the y-axis at y is equal to 1, because if x is 0, y is 1. So we see that we have got 2 triangles. This triangle lies above the x-axis. It gives a positive contribution to the definite integral. This triangle lies below the x-axis, and so just like here, this is going to give a negative contribution to the definite integral. And a geometric understanding of a definite integral is that this integral is equal to this area minus this area. all areas are positive, but this area, because it is below the x-axis, gives a negative contribution to the value of the integral. Now, if you look at these triangles, they look fairly similar, so we think this integral is going to be small, and actually you can easily convince yourselves that these two triangles have the same area. The area of a triangle is a half the base times the height. So the base of this triangle is 3 halves because it goes from -1 to a half. So it's 1 plus a half, 3 halves. The base of this triangle is a half and then 1, so it's also 3 halves. And the height of this triangle is 3, and the height of this triangle is also 3. Notice the height of this triangle is not -3, it is 3. It is the length of that side in whatever the units would be. So, these two triangles have the same base and the same height. Their areas are going to be the same. Because of the minus sign, that means they will cancel. And I've just put the numbers in here. And we see, therefore, that this definite integral will vanish. So, on the next slide, I'm just going to calculate the integral rapidly and give you another example that you're very welcome to look at afterwards. So, just to quickly check our work above, here is our integral. The integral of 1 is x. The integral of -2x, well, we have -2. We add 1 to the power, this is x to the 1, so it's x to the 1 plus 1, x to the 2. And then we divide by our new power, and we see that the 2 and the half here will cancel. So we have x minus x squared. At the upper limit, we have 2 minus 2 squared, so that's 2 minus 4. And then we write a minus sign, and then we work out everything in here at the lower limit. And I think after the minus sign, it's very good practice to open a big bracket. So at the lower limit, this is -1, and then we subtract -1 squared. -1 squared is +1, so we have -1 minus 1. We have -2 in this bracket. 2 minus 4 is -2. So we have -2 minus -2. So that's -2 plus 2. So they are going to cancel. So our integral is going to vanish as we expected based on our geometric understanding of what the integral means. So having calculated this integral in this way, I will just give you another possible exercise to work out and think about, and I will draw that for you now. So I'd like to suggest that you use geometry to calculate this integral. And the answer that you should obtain is 8 pi. You don't need to calculate it using techniques of integration. You just need to use geometry. And on the next slide, I will just draw something which will, I hope, make it clear to you why this is the case. So if you decided to have a go at the last exercise, the key idea relating integrals and geometry is that you sketch the integrand. The integrand here is the square root of 16 minus x squared, and that means that y squared is 16 minus x squared if you square both sides. If we bring the x squared over to here, we have x squared plus y squared is equal to 16, which we can also, of course, say means it's equal to 4 squared. This is the equation of a circle of radius 4 centered at the origin. So if we want to draw the integrand, The integrand is the square root of 16 minus x squared. Square root is by convention positive, so therefore this is the curve of our integrand. It is a semicircle going from x is minus 4 to x is 4, and its maximum value is 4 when x is 0. And all of this is above the x-axis. Again, the square root is positive, so it's clearly going to be positive. And this area here is half the area of a circle, pi r squared. Our radius is 4, so the area is a half pi times 4 squared, 16, so it is 8 times pi. So this is the value of our integral, which you could calculate using somewhat more sophisticated techniques, but geometry gives us this example for free. And with that, I'll stop this video.